Hello everybody and welcome back to MrMiers Math Channel. Today in Algebra 2AB we're going to go over section 8.5, which is talking about properties of logarithms. And we're actually just combining both days here into one. So we had separated it before into day 1 and day 2, and we're just going to combine both. So what we're going to be talking about is using properties of logarithms to let's say condense and expand expressions. All right, so we're going to have multiple logarithms that we're talking about, and we're going to talk about either combining them into one or maybe taking one logarithm and separating it into two. And there might be a lot of different reasons we might do so. Some of those reasons might be it's easier to evaluate if we separate it or combine it. So let's get into it. So we're talking about properties of logarithms here. Let's just say b, m, and n are just some positive numbers such that b isn't 1. So the base of the logarithm is not 1. So our product property, and we can use this either to expand it or combine it, and combining it means, making it smaller. Expanding it means separating it into two separate logarithms. We can use that property if we notice that log base b of mn, which essentially would be just one number, but if we know that one number is has multiple factors, we could separate it into log base b of m plus log base b of n. All right, the quotient property would state that log base b of m over n would just be log base b of m, the numerator, what was in the numerator before, minus log base b of n, what was in the denominator. All right, and then the power property, log base b of m to the nth power, okay, we could rewrite as n times log base b of m. All right, so we're going to use these rules to either condense the expression or expand the expression. And remember, these rules are something that we just find over time, okay? We could do some simple cases and prove some simple cases are true, and then over time we figure out, oh, actually it's all true. Okay, we could write a literal proof for this and show that these properties work all the time. All right, so in example 1, we're going to condense the expression. It says log base 2 of 7 plus log base 2 of 5. Key thing here is we can only condense this expression if the base is the same. If the base isn't the same, we can't condense the expression using this exact property. All right, so since the bases are the same for these logarithms, we keep the same base. Okay, just like with our exponent rules. Remember, logarithms are like exponents. So we keep the same base. And now, since it's saying plus, that indicates the product property. So that would be 7 times 5, which would be 35. So that's just log base 2 of 35. All right, and of course, we could find what that value actually is, but that's not what the question is asking. We're just trying to use these properties to condense the expression. All right, and now in this one, we have log base 5 of 12 minus log base 5 of 4. All right, subtraction would indicate the quotient property. So really what we're talking about is log base 5 of 12 over 4, which is just log base 5 of 3. All right, now moving on. Now we're going to see some product rules. So in part A, we have log of 16, and remember the implied base there is 10. And minus 2 times log of 2. Once again, the implied base there is 10 as well, so we can use these properties. First, before we do anything, though, we might want to rewrite this. All right, use the product property, or sorry, not the product property, the power property, and rewrite this as log of 2 squared. Well, we know what 2 squared is. That's 4. So I'm just going to rewrite this again. So this is log of 16 minus log of 4. And now we can use the quotient property, which means this is just log of 16 divided by 4, and we know 16 divided by 4 is 4. So obviously what we end up with It is much simpler than what we started with, and that's the whole point. When we say condense the expression, that's what we mean. All right, in the next example, we can rewrite 3 log of 5 using the power property as log of 5 to the 3rd power. I'm going to rewrite the rest. Now we might want to simplify that. So 5 to the 3rd power, that's 125. Now we have log of 125 plus log of 4. Since it has the same base, which is that implied base of 10, we can combine these expressions, and we would multiply 125 times 4, and we get 500. Awesome sauce. Now to part C. We have log of 4 plus 2 times log of 3. Once again, let's rewrite this. So in condensing the expression, most of the time, if we see power property, we're going to want to do that first. In condensing the expression, that's key. All right, now log of 3 squared is really just log of 9, because 3 squared is 9. Now log of 4 plus log of 9, we're going to multiply these, and we get log of 16. Sorry, 36. Words today, man. All right, for part D, we get 3 times log of x minus log of y. We're going to rewrite using power property. So this would be log of x cubed. Now we can't simplify that, because we can't evaluate x cubed. So we have log of x cubed minus log of y, and that subtraction would indicate quotient property. So this would be log of x cubed over y. All right. All right, cool beans. Now, let's do one really difficult one. And this actually isn't a really difficult one, but it just looks like it. So we have log base 2 of x plus log base 2 of y plus log base 2 of w plus 5 times log base 2 of z. First thing, we could take a look at this, all right, and we could use that power property. So I'm going to rewrite all of these, and notice all the bases here too, so that's nice. That means we can condense this. We're going to have log base 2 of z to the 5th power. And now, since all of the bases are the same, we can condense this whole thing, and notice we see addition for all of these, which is nice, because that means we're just going to multiply the arguments. So that's log base 2 of x, y, w, z to the 5th. We're just multiplying the arguments in each one of these. That's it. So I said complicated. It wasn't that bad. It just looks complicated. All right, now we're going to talk about expanding expressions. And this was usually day 2, where we're combining it all into one. So expanding expressions is just basically the opposite of condensing expressions. We want to separate this into individual parts, because maybe we can't simplify it at this point. And if we separate it into its individual parts, we can simplify the individual parts, and that will help us figure out what the whole thing is. All right, so in part A, we're going to separate this, and we have to understand what's happening with the argument here. That's really important. This is 5 times x squared. All right, so 5 times x squared. Note that that square is not squaring the 5, it's just squaring the x. So maybe the first thing that we want to do is separate it using the product rule. Okay, so we could rewrite this as log base 4 of 5 plus log base 4 of x squared. So as before, where we would have used the power property first in condensing, we're actually going to use the power property last in expanding. And I'm just saying this happens most often. Okay, not all the time. There's always exceptions. Now we're going to use that power property to separate or to rewrite log base 4 of x squared. Now that exponent just goes right in front and multiplies by the logarithm, so that's just 2 times log base 4 of x. In part B, we have log base 7 of 3x on y. So this would be using the quotient property, okay, if we wanted to separate it that way. So that's log base 7 of 3x minus log base 7 of y. Now we're not done yet. We could still simplify even further right here. All right, this is 3 times x, so we could separate that into log base 7 of 3 plus log base 7 of x. And then, of course, minus log base 7 of y. So we're just separating it into its individual parts. All right, moving on. We're almost done here, actually. Got a few other examples, a few trickier examples. Part C is not actually trickier than the ones that we've done so far. So first thing that we would want to do is maybe separate it using product rule. So log of 2 plus log of x cubed. And remember that base is 10, and the base is 10 for each one of these that we write down as well. Now use the power property. So we have log of 2 plus 3 times log of x. In part D, once again, maybe use quotient property first. And we have log base 3 of 5x minus log base 3 of 7, and then separate this using the product rule, or product property. We have log base 3 of 5 plus log base 3 of x minus log base 3 of 7. Now we got to remember our rules for exponents in parts E and F, okay, because the square root of x we could rewrite. The square root of x is just x to the 1/2 power. So I may start by just writing this as log of x to the 1/2 power. And then we could use our power property and rewrite this as 1/2 times log of x. Same thing for part F, okay? The cubed root of u is really just u to the 1/3 power. So I'm just going to rewrite it like so. Log base 3 of u to the 1/3 power. And that makes this pretty easy to rewrite. That's just 1/3 times log base 3 of u. Awesome. Making some headway here. I'm going to clear the board and let's move on. This is the last one. Okay, expand the expression. We got a lot of variables here, just like the previous challenge problem, challenge in quotations. We have another challenge problem for expanding the expression. All right, and this one's actually not so bad. All right, what we see in the argument of this logarithm is a lot of multiplying. Right there, there's some implied multiplying here between x and the cubed root of u. So we could separate that using the product rule. So that makes this log base 5 of v plus log base 5 of w plus log base 5 of x plus log base 5 of, I'm going to write this as u to the 1/3 power. And then we could use our power property and write this as log base 5 of v plus log base 5 of w plus log base 5 of x. And now to simplify this, we're going to rewrite it as 1/3 log base 5 of u. All right, folks. I know that was a lot of interesting stuff that we just looked at. Where we're going to use this is in the next section when we're talking about solving exponential and logarithmic equations. So really we're just getting the skills to be able to use these logarithms, and now we're going to use those skills for logarithms and exponents, those techniques that we've looked at in the previous sections to solve exponential and logarithmic equations. All right, folks. Thank you. If you enjoyed it, hit the like button, subscribe, and have a great day.